Hey everybody, so today we are going to solve another daily LeetCode challenge, problem number 47, Permutations 2. So the problem is, given a collection of numbers noms that might contain duplicates, return all possible unique permutations in any order. So for example, here, if you're given 112, the answer should be 112, 121, 211. So remember, if we are given n elements, the total number of permutations that we can generate is n factorial. So given 3 elements, we could generate 6 permutations. While we are having 3 here because of this limit that the problem is asked that to return all possible unique permutations in any order. In order to implement in Python, so there is one permutation function already built in Python that you can use by importing itertools. So I'm first going with the easy way and using this function and just solve the problem. And then after that, we are going to implement the permutations ourselves. So if you import itertools and then there is a permutations function here and you just pass the noms. So that's it. So basically it is already generating all permutations in given an array. But this object is in Python is a generator function. So I need to convert that to list first, and then let me print that. Then return none for now, just to see what we have. As you can see, given 3 elements, so we are having 6 different permutations here. But we are asked to return all possible unique permutations in any order. So for that, I'm going to implement some helper functions that given an array, so let's define a new problem. Given an array, first we are going to convert that into a unique array. So we are removing all elements in the array that are duplicates. So the easiest way, or one of the easy way, is to convert an array into a set and then convert it back into array. So for example, if I have my list 1, 1, 2, and 3, I could simply do that in Python using list of set of L. So first, by converting a list into a set, the set is automatically removing all duplicates. So it's gonna be, it should be 1, 2, 3. And then I'm just converting that back into a list because the problem is asked us to return a list. But the problem here is that if we are given the objects are not hashable, sometimes if they are a list, we cannot do that. We can only do that by tuples, strings, and integers, which are hashable. So for that, I'm first going to implement helper function. Here, convert to, then array, the element, the second element is target. I'm going to convert to tuple. So I'm gonna say why I'm using that, because first, let's implement it for tuple. If target, or let's say for readability, let's say dtype equals tuple. So I'm converting all elements in the array into tuple and just returning. Otherwise, if dtype equal to list, then I'm using this function to first convert it to tuple, then use our convert to list so that remove the duplicates. But after that, since as you can see in the example, we need to return all objects in the list, so I need to convert them back, and that's why I'm going to use the same function but with different parameter. So here, the list of elements for element in array else return none. And the second helper function I'm going to use is remove duplicates given an array. So first, hashable array is convert to, so we are converting all elements in the array into tuple. And then unique array is the list of set of this had already the items that converted to a tuple. And then we are returning a list version of this unique array. So I'm calling remove duplicates from this list. There we go. So this is the answer by using the permutations function in the tools. So let's just try the next one to see if everything is working fine. Okay. But let's now implement our own permutation. So my permutation. So I'm going to use a recursive procedure here. So given an array, my function should generate all permutations here. But if the length of the array is less than 2, what we are returning is the array, it is already the maximum number of permutations that we can generate. So we are just returning a list that contains the array itself. So for example, if the array is equal to 1, then we are returning a list that contains only 1. But for another example, if the array is 1, 2, so let me push it on top. So if the array is 1, 2, so our function should return 1, 2, and 2, 1. Okay. So now this is the boundary that makes our recursive function stops when it comes to an array that only contains one element. And the idea is, first, I'm gonna split the array, extract the first element and the rest of that. So first and rest is the first element in the array, and then the rest of that using like this. And then n is equal to the length of array. So recursively, I'm gonna call the permutation function, our permutation function, on the rest of the array. So let's first create that. Rest permutations equals my permutation on rest. So this function generates all permutations in the rest of the element in the array. And let's take an example here. So given 1, 2, 3, let's say we have the function that returns all permutations for 2 and 3. To generate all permutations, if you just look at 1, so 1, in some cases, it can be in the first position, in the first index, and then the rest. It can be on the second index, and it can be on the last one. So the idea is we are first generating all permutations for the rest of that, so it doesn't matter what we have here. And we are iterating through the length of array, so in this case 3, and then we are inserting the element in the first, second, and third index. So let's implement that. Then for different combinations for permutations in rest permutation. So let's say we have a result. So we are storing a new permutation that we find in this result, and at the end, so we are returning the result. So the new combination is, so as we are iterating through I, so first perm up to index I plus the first element plus the rest of permutation. So we are iterating through all permutations that we found recursively, and then inserting the first element in the first iteration into the first index, then into the second index, then to the third index, and so on. And then this is a new combination that a new permutation that we found, and then we are adding that to our result. New, let's rename it, so permutation. Okay, new permutation. Okay, let's run that to see what we have. Okay, there we go. So if I change it to test it, let's, never mind. So we are still using the iter tool. So let's remove that and replace it. So let's have it here and use the same function over our own my permutation knobs, and then let's debug that. Oh, 1, 2, 3. Okay, there we go. Now we are using our own permutation. Okay, let's submit that to see if it works. Okay, there we go. So it is that, but we can compare the function. There are different ways to generate the permutations. You can find different algorithms on Wikipedia and elsewhere. But let's compare our own function with the built-in Python function, to compare the result. So that's fair. As you can see, our implementations finished the test case in 300 milliseconds, but the default function, permutation function in Python, finished all test cases in 150 milliseconds. All right, so that was everything for today's daily challenge.